Welcome to this explainer on RAG, or how AI gets the right information before answering. So look, if you use modern AI assistants, you already know how incredibly powerful they are, right? But they have a massive blind spot that fundamentally limits their use in the real world. Basically, they don't know your secrets. Today, we're going to demystify exactly how AI can securely access your private specific data to overcome this limitation. By the end of our time today, you'll understand the exact mechanics behind how the smartest systems in the world are getting even smarter. Let's dive right in.
I want you to imagine, just for a second, typing this exact prompt into your favorite AI model. What is the leave policy in my company? Now, the AI might be incredibly smart, but how could it possibly know the answer to this? Well, it doesn't. Your company's internal policies, your private databases, your specific customer records, none of that is public. It is locked away. So when you ask a standard AI this question, it hits a literal brick wall. It might try to give you a generic answer about, standard corporate leave policies, but it absolutely cannot give you your actual answer. To make AI truly useful for your daily work, it needs access to your specific reality. Enter our hero's solution, Retrieval-Augmented Generation, or RAG for short. It's about giving an AI assistant a search engine and a library to look up relevant information before generating an answer. The concept is actually beautifully simple. Think of RAG as giving an AI its very own dedicated search engine, paired with a highly customized library. Instead of forcing the AI to rely solely on the massive, but entirely static, pool of knowledge it memorized during its initial training, RAG grants the AI the power to actively search for facts, retrieve specific documents, and actually read them right before it formulates an answer for you. It's literally the difference between asking someone to answer a complex trivia question from memory versus letting them look it up in an encyclopedia first.
So the crucial point here is understanding the underlying problem with normal AI models that makes RAG so absolutely necessary. How many days of annual leave do I get? What is the reimbursement process? Let's say you build a standard chatbot for your company without RAG. Your employees log in and ask totally normal everyday questions exactly like those. Because your company's internal PDFs, Word documents, and HR manuals were absolutely not part of the model's original public training data, the AI is completely in the dark. In a best-case scenario, it tells you it doesn't know. In a worst-case scenario, it confidently guesses, or hallucinates, giving your employee an outdated or entirely incorrect process to follow. And let's be honest, that is a massive operational risk.
RAG solves this hallucination problem by operating in three distinct steps: retrieve, augment, and generate. First up, we retrieve. When a user asks a question, the system actually pauses. It doesn't immediately spit out an answer. Instead, it acts a lot like a librarian, searching through your secured company documents to find the most relevant sections that match the intent of the question. Second, we augment. The system takes that specific retrieved information and essentially staples it to the user's original prompt, augmenting it with real, tangible context. And finally, we generate. The AI reads the combined package, the question plus the newly found facts, and generates a clear, accurate, natural language response. Retrieve, augment, generate. It really is that straightforward.
Let's ground this in a real-world example to see why this process is so incredibly efficient. Imagine a 200-page employee handbook PDF, and we're searching for the maternity leave policy. Theoretically, you could try to copy and paste the entire 200-page document into the AI's chat window every single time someone asks a question. But doing that is incredibly slow, highly inefficient, and usually completely exceeds the memory limits of the AI model anyway. Instead, the RAG system searches the handbook in the background lightning fast. It finds just the 3 specific paragraphs detailing maternity leave, pulls only that tiny section out, and feeds it to the AI. The AI doesn't need to read the whole book every time, it just needs the relevant page.
Okay, so how does it actually find that specific page so quickly? Let's peel back the curtain on the technical pipeline. Collect documents, break into chunks, convert to embeddings, and store in a vector database. First, we collect the documents: PDFs, websites, internal wikis, the whole shebang. Second, because these documents are massive, we break them into chunks. Basically, we slice a giant manual into hundreds of digestible, paragraph-sized pieces. Third, and this is the absolutely critical transformation, we convert those chunks to embeddings. We take human words and translate them into massive mathematical arrays that capture the actual semantic meaning of the text. Finally, we store them in a vector database. This is a highly specialized database designed to hold and instantly search millions of these numerical embeddings. It is the core engine powering the entire retrieval process.
So, when you sit down and type your question into the prompt, your written question is instantly converted into an embedding too. It becomes a mathematical representation of your intent. The system compares the math of your question against the database, looking for a semantic match. It's basically finding the puzzle pieces that perfectly align with your intent, rather than just doing a simple, clunky keyword search. Once it finds the closest mathematical matches, it retrieves those specific text chunks, pulls them right to the surface, and hands them directly over to the language model to read.
Honestly, think of it like taking a massive open book exam where you have to find the index, read the chapter, and then answer the question. If you're asked a highly specific question about photosynthesis, you don't start reading the entire 1,000-page textbook from page 1, right? No, you use the index, flip to the exact chapter, read those specific paragraphs, and then synthesize your answer. RAG is simply an automated, lightning-fast version of that exact strategy.
To really cement why this is a total game changer, let's directly contrast the two systems. A normal large language model relies entirely on its static training data. If its training cutoff was last year, it has zero knowledge of anything that happened this morning. It's smart, for sure, but it is frozen in time. A RAG system, on the other hand, combines that training with external, up-to-date information. It beautifully bridges the deep reasoning capabilities of the AI model with dynamically refreshed data. If you update your company's HR policy at 9 a.m., your RAG chatbot will instantly start giving perfectly accurate answers based on the new policy at 9:01 a.m.
Because RAG bridges this knowledge gap, it is absolutely transforming industries across the board. We're talking customer support, company knowledge bases, document question answering, research assistance, and technical documentation. Instead of lawyers sifting through thousands of case files or new hires struggling to find decades-old institutional knowledge, RAG acts as a tireless, brilliant research assistant. It can power customer support that actually knows a user's specific order history, or navigate incredibly dense technical documentation in seconds. Basically, wherever there's a massive pile of text that humans struggle to sift through quickly, RAG provides an elegant, highly scalable solution.
But hey, I want to bring us back to reality for a quick moment with a really crucial caveat. Good retrieval leads to better answers. RAG is incredible, but it doesn't make AI magically omniscient. The old garbage in, garbage out principle heavily applies here. If your vector database retrieves the wrong paragraphs, the AI is going to generate a beautifully written, highly confident, and entirely wrong answer. For instance, if you ask about maternity leave and the search engine accidentally retrieves the cafeteria menu, while the AI might confidently tell you your leave policy involves Taco Tuesdays. The quality of a RAG system rests entirely on just how good your retrieval engine is.
And that brings us to our ultimate takeaway. Don't make the AI guess. Let it look up the information first. Separating the reasoning engine from fact storage is what really transforms AI from a cool novelty into a reliable daily workhorse. Now, you might be wondering exactly how those vector databases actually search millions of abstract concepts in a single millisecond. Well, wouldn't that make the perfect topic for your next deep dive? Keep exploring, and I'll catch you in the next explainer.